This conference will now be recorded.
Now, my dear friends, in this session, we are going to learn about switch, how the switch works. And we are going to learn about the story of Destination Mac, and we are going to learn how the how the switch works. And we are going to learn about something which is known as the ARP broadcast packet. So it will be a very interesting session and it is very important. So my dear friends, let's start. So what we are going to do is in this session, we are going to take a switch, and we are going to take three PCs, PC1, PC2 and PC3. We are going to take three PC. This is like PC1. This is PC2 and this is PC3. And my dear friends, we would be giving IP address to this PC. The first PC, we would give the IP address like 192.168.1.1. And automatically a subnet mask will come, that is 255.255.255.0. We will just give the IP address and not the default gateway, not the DNS. Okay. So my dear friends, at this point, we will give the IP address. In the next session, we will give the default gateway also. For the default gateway, we need to have a router. So in this session, we will learn switch. In the next session, we will learn about routers. So we will go step by step. So the thing is, we just need an IP address. Now you might be thinking like, why we are giving 192.168? Why is this like 192.168.1.1? Like, why this IP 192.168 only? So do not worry, there is a complete lecture on IP address where we are going to learn about IP addressing in depth. There are two versions of IP address. This is known as the IP address version 4. There is a version 6 also. Normally version 4 is very commonly used. Okay. And in this, there is a concept of private IP and public IP. So in this lecture, you will get a clarity about IPv4 and IPv6 address. You will get a clarity about the public address, public IP, what is the public IP, what is the private IP address. And my dear friend, you will get an understanding about the subnet mask also. Like what is the meaning of 255.255.255.0? It has a meaning. So all these things we will understand at the right time. It is little bit a session where practical is little less, so we have taken it ahead. At the right time we will take it when it is required. Okay, so we will understand switch, we will understand routers, we will configure the switch, and we will configure the network devices. We will do a lot of practicals, and then at the right time we will understand about the IP addressing part. So my dear friends, anyways, IP address is required for communication, and without IP address you cannot do communication. So IP address which is commonly used in the world is 192.168 series. This is commonly used. Even if you see your laptop or computer IP, you might see if you do ncpa.cpl, you're connected via internet right now in the meeting, and you will see your computer IP might start with 192.168. So IP address is required for communication, and along with IP there is subnet mask. This is also required. This we will understand the importance of subnet mask in subnetting. So IP address we have to give. Without IP address, communication cannot happen. And you know, two things we have understood, that along with IP address, then there is one more address which is required for communication. Right? Do you remember? There was one more address which was required for communication along with IP address. Along with IP address, there is one more address which is required for communication, and and that address is the perfect. That address is the answers are good. Okay, whatever comes in your mind, you can share. Even I can some meaning it is good. So yeah, I can share something with you. You can share with me. So the answer is, at this point I was looking for the MAC address. So Along with IP address, we need MAC address. Okay, so MAC address is by default given. When you buy the device, automatically it is there in your device. You buy an HP laptop, Dell laptop, automatically it is there. It is given by the manufacturer. But IP address, we have to control, we have to give. Now, so what we are going to do is we are going to take a switch and we are going to take 3 PC, and MAC addresses will be there in packet tracer, and IP address we have to give. So the first computer, we will give the IP address as 192.168.1.1. Subnet mask will be as it is. Whatever subnet mask you will get, you will keep it as it is. The next computer IP address you will give 1.2. The third computer IP address, my dear friend, you will give 1.3. Now, after giving this, what we are going to do is we are going to perform a ping. We will go to this PC1, and if I want to check whether I am reachable to PC2, whether I am reachable to PC3, what I will do is I will do a ping. I will go to this computer and I will do a ping 192.168.1.2, ping 192.168.1.3. So when I do a ping, we all know our PC will create an ICMP echo packet. So let's go ahead and let's see this in action. So my dear friends, please open up the packet tracer. Okay, please open up the packet tracer, and then we have to do this lab. This is a small lab, but slowly we will go ahead. So please open up the packet tracer and come on this page. Okay, so have you opened up the packet tracer? You have to give me the confirmation, as because you have to put in the comment box like yes or something like this. So that's great. Okay, now my dear friends, let's take the switch. Okay, so here what we have to do is you have to click on the network device. On this part is the network device, and this is a router, and next you have a switch. So click on this network device, which is already ticked there. You have to click on switch. So have you click on switch? Switch. Okay, that's great. Now here you have to take 2960 switch. 2960 switch is also known as you in companies access switch or L2 switches. These switches are used to connect your computers. So then you might see some 3560 switch. It's an L3 switch. We are going to learn about L3 switches also. L3 switches are equal to router, and they are better than router. Okay, so we will come to L3 switch at the right time. First we will take this 2960. So please take a 2960 switch and drag and drop. So my dear friends, can we get 9200 switch? As of now it is not required. In my case I don't have anything, but normally we go for 2960. This is the normal access switch. Then there are a lot of switches model. The concept of all these switches are same. Only port number will be different. This switch might be 100 Mbps supporting. Some high-end switches might be 1000 Mbps supporting. 2960 is not there. 2960 is not there. Okay, so what is there at your site? 2960 is not there. Then which switch is there, my dear friends? Santosh bhai, I need to make you the presenter. So anyways, I was not able to make you the presenter, meaning I was not able to take your screen. So do you see the first switch? Everyone can, do you see the first switch? Drag and drop it. Do you see the first switch? 2960. 2960. Just drag and drop it. Okay. So you see 2960 switch. Okay, that's great. Now, my dear friends, what you have to do is you have to click on computer. Do you see computer? Computer, computer. Click on computer. Computer. Just click on computer. And when you click on computer, you have to drag and drop, or you can say when you click on computer, you will see the first computer as the PC. So there are laptops, there are servers. So just take the first one, drag and drop. First see on the screen and then do it. Drag and drop, drag and drop, drag, left click. All is the game of the left click. So drag and drop, drag and drop. So my dear friends, have you taken 3 computers? Okay, that's great. Now what you have to do is you have to connect the 3 computers to the switch. Now how you are going to connect the computers to the switch? You have to click on this cable. You have to click on this cable and you will see the first cable. Just look on the screen. You will see a flash icon like this. And you have to click on this icon, the first one itself, the left click, and then click on the computer, click on the switch. Okay, done. That's good. Click on the click on this. You will see a no entry board. Then click on the computer and click on the switch. Then once again click on this and you will see a no entry board, and then click on the computer and click on the switch. So my dear friends, this is how you have to do. You have to connect to the click on this and you will see a no entry part, and then you have to click on the computer, click on the switch. It is like the cabling is done. That's great. And if you face any problem, you can update me right away. So I will take your system's remote and I will help you out. So my dear friends, my request to everyone is if you are facing any problem, you have to update right away. Okay. If you update after 5 minutes, 10 minutes, 15 minutes, it will be tough for me and it will be tough for everyone, and you will become the student of the class. Okay, so update at the right time. Now coming back, my dear friends, so in this case what we have to do, we will use this comment box. Okay, so for your if you want, you can use this comment, but I would be using this comment multiple times so that you can see on the screen and you will have an idea. What I will do is just above this physical there is a comment box. It is optional for you. If you don't do also, that is fine, but if you want to do, you can do it. Just above physical there is a comment box. If you click on the comment box and click here, the comment will come. Okay, if you left click here and left click here on this space, a comment will come. There you can give the IP 192.168.1.1. So this is the IP address which we are going to give, okay, to this computer. This is the, then I can just press the escape button, then I can click again 192.168.1.2, then escape button, and then click again 192.168.1.3. So this is for your understanding. Comments are for your understanding. Now we have to give the IP to the computers. So my dear friends, let's give the IP address to the computer. Now how to give? Let's do it. These are the computers which are given to us by the packet tracer. So here we have to click on this computer, click on this computer on the left hand side, and you will come on this page. So the computer looks like this. This is the cabinet of the computer. So are you on this page? Okay, that's great. Now you have to click on a desktop. Do you see desktop? You have to click on desktop. Desktop. Now, after clicking on desktop, do you see IP configuration? Now, my dear friend, you have to click on the IP configuration. And now we would be giving static IP. Okay, here we would be giving static IP. And in real life, it is like this. In real life, it is like going to a computer which is having Windows operating system and typing the command ncpa.cpl. This is the command. In real life, it is like this. So typing this command ncpa.cpl and clicking on the LAN card, and then Ethernet is the LAN connection, while this is for wireless. So in companies, normally you'd be connecting via Ethernet. So if you are connected via Ethernet via LAN card, then you have to click here, meaning there is a cable connected to your computer. Then you have to click on Ethernet and properties, and here is the IPv4. IPv4. Okay, so I will just repeat this, double clicking here and going to properties and going to IPv4, and then use the following IP address. So this is the same thing here. The same way Cisco has given you the option. Okay. So Cisco says that it is the same thing. You go to the computer, you go to your computer and you give the IP address. The same thing you are giving here like this. So it's a dummy computer, but it will work as a computer. So IP address, subnet mask, default gateway, and DNS. Okay. So IP address, subnet mask, default gateway, and DNS. And there are two ways to give the IP. One is static. One is when you give manual IP address like this, you type the IP, subnet mask, default gateway, and DNS. Then it is known as manual IP, static IP. And other is when your company is having a DHCP server, then you can say obtain IP address automatically. So both options are available, static and DHCP. Both options are available here also. Okay. Now, my dear friends, DHCP we are going to learn at the ending of this session of this course. We will be making a router as a DHCP server. Then at that point, I will explain you what is DHCP. So at this point, we will give the IP manually, which is known as giving static IP, fixed IP. So IPv4 address we are going to give, that is 192.168.1.1. So when you give the IP, automatically the subnet mask will come 255.255.255.0. We are going to learn about subnet mask. There is no need for you to give default gateway. Default gateway and DNS is not required in this lecture. Okay, just you need to give the IP address. So my dear friends, just go ahead and give the IP address to your computer like this. Okay, that's great. And while giving the IP address, you should not make a mistake. My observation is some people make mistake while giving the IP address. Sometimes they just type 192, or sorry, 192 is missing. Sometimes the dot is not there. Okay, sometimes they just type 16 instead of 168. So the IP address has to be like this: 192.168.1.1. Okay, and one powerful formula I would like to share with you people, and that powerful formula is known as always cross checking your work. So my dear friends, at whatever level in the company you are, at the initial level or at the top level, always cross check your work. So if you cross check, you will always find that it is so beautiful. Instead of others finding fault, if you find the fault and resolve your own issue, it is very good thing. So my dear friends, now the IP is given. There is no save button here. Okay, there is no save button. You just need to go ahead and click on close. Okay, there is a crossbar here. You just need to go ahead and click on close. So IP is given. If you want to cross check, you can click on IP configuration and cross check. IP address is there. Done, my dear friends? Have you given the IP address? Okay. Now, if you want to check the IP and the MAC via command line, the way in your computer, if you type the search bar and there is a command line, CMD is the command prompt, CMD is the command prompt. Okay, and you can see there is one more git command prompt. This is something different. So this is the normal command prompt, and if I click on this command prompt, so I will come on this black screen, and if I type here the command ipconfig, okay, ipconfig is the command. So I can see the IP address here. Okay, in my case there are a lot of adapters, so I can see a lot of things, but I have to focus on Ethernet. LAN cable connection is known as Ethernet. So here I can see my IP, that is 192.168, but I'm not able to see the MAC address. Okay, I can only see the IP address subnet mask default gateway of my LAN connection. I have lot of adapters, wireless adapter and some other adapters. That's why I see a lot of stuff, but here this is the main thing. And the next thing is, if I want to see in detail, then I have to say this slash, this forward slash and all, ipconfig space slash all. So my dear friends, if I just go ahead and type this command, then for my Ethernet Ethernet adapter, not VMware word, only Ethernet adapter. So Ethernet adapter is my LAN connection, and I can see the DNS also, and I can see the physical address, which is the MAC address also of my computer. So if I say ipconfig space slash all, I can see the physical address, that is the MAC address, and I can see all the details once again, IP subnet mask default gateway, but I can see the details of the DSCP or the DNS, details in depth. The same way here, Cisco has given you the command prompt. Okay, so click on the command prompt, and my dear friends, you can type the command ipconfig. Okay, so just go ahead and type the command ipconfig, and you will see the fast Ethernet connection. Wherever you see fast Ethernet, meaning 100 Mbps, meaning this computer support 100 Mbps of data transfer. So Cisco has not changed anything, meaning they say that, okay, actually in today's world, all the computers support 1 Gbps of data transfer. All the computers are gigabyte Ethernet, meaning they can support 1 Gbps of data transfer. But Cisco says, okay, fine, you're not actually going to transfer any data in packet tracer. So do you see your IP address? Okay, now also type the command ipconfig space slash all. So my dear friend, I also type the command ipconfig space slash all. Ipconfig space slash all. Now in this batch, there are senior people also. There are junior people also. So for some, the command can be redundant, but for some, the command is new. Okay, my dear friend. So obviously, as we have to take care of everyone. Now I am not getting. Okay, so Archana ji, we will make you the presenter, and we will see what's happening on your system. But whenever I make anyone a presenter, okay, you have to give me the keyboard and the mouse control, because I cannot guide anyone. Click here, click there. We do not have that much time. Okay, we do not have that much time, and your screen will be shared with everyone. Everyone will see your screen. That's why whenever you join GoToMeeting, before joining GoToMeeting, close all your browsers, all your important companies browsers and everything, just close it up and only keep GoToMeeting and what packet tracer, all these things in front of you. So here you have given the IP, you have to close this, you have to close this. There is a crossbar, you have to close this, you have to close this. Okay, now that's what I'm telling, because that's what I'm telling, because guiding is, it is very, very, very tough. Now you have to double click on PC1, double click on PC1, you have to double click on PC1. Okay, I will help you out like this. Okay, the point is I can help you out like this. I will close this. Double click on PC1, double click on your computer, double click on your computer and click on desktop, and you will see command prompt. Do you see command prompt? Now you will see command prompt. Now click on the command prompt and then you will see ipconfig space slash, you have to run this command ipconfig space slash all. Okay, you have to run the command ipconfig and ipconfig space slash all. In ipconfig space slash all, you people can see the MAC address also, the IP address also, and all the details in depth. Now what I am going to do is, for your understanding, I would be copying the physical address, okay, because I have to show you something. So I will copy this physical address. There is no need for you to copy because I have to show you something. So I will copy this physical address and I will put in my comment box. Okay. So I will close this. You can just look on the screen. I've done nothing. I've just clicked on the command prompt, run the command ipconfig space slash all, and I have copied this. Now I have closed this, and then you can also close this. Okay, you can also close this computer. So first computer IP address setting is done, and I will paste this MAC address here. I want to show you something, so I need the MAC address also. Okay, so the first computer everyone has given the IP. Now my dear friends, let's go ahead to the next computer. Okay, so see on the screen, click on next computer and click on desktop. Click on desktop. Are you on this page? And when I take the remote, just give me the keyboard and the mouse control also, because I have to just sync you up and come back to my screen. Okay, so I have to just, if you're lost, I have to sync you up and I have to come back to my screen. And Attari Class is a reputed organization. So you can believe on us. Okay, my dear friends, some people have I'm generally saying some people have different thoughts. Okay, that what will happen of my computer. We are not we are simple people. Okay, we just want to help you. We just want to take the remote, put you in sync and get back to our system. Okay, because if I do not get the keyboard and my mouse control, upcoming sessions complexities will increase and we are going to learn a lot of things, and I will not be able to meaning guide you up verbally because you do not have an idea about the interface or what command you have to type. So I will just quickly take the remote, type whatever I want, put you in sync, and I will come back on my screen. Okay, this is what I do in all the lectures. So my dear friends, coming here, one more thing, not possible to follow. So Santosh Bhai, have you given the IP to the computer? Is there anyone who has not given the IP to the computer? Clicking on PC, clicking on IP, you have not given the IP to the computer. Is there anyone who has not given IP to the computer itself? My dear friend, is there anyone? Okay, no one. That's great. Okay, that means people are able to follow. Now, the next thing is you have to click on the middle computer. Okay, you have to click on the middle computer. Okay, you cannot meaning is your internet slow? Are you able to understand this, Santosh Bhai, that when I'm telling click on the middle computer? Okay, when I'm telling click on the middle computer, then click on the middle computer and click on desktop. When I say click on desktop, then you have to click on desktop. Simple. So my dear friends, just click on the middle computer and click on desktop. So are you on this page? Okay, now after coming on this page, you have to click on IP configuration. Okay, IP configuration, IP configuration. Have you clicked on IP configuration? Now, are you on this page? Okay, that's good. Now you have to give the IP address, which is 192.168.1.2. You have to give this IP address 192.168.1.2 and just press the tab button. That's it. Subnet mask will come automatically. And nothing you have to do. Just give 192.168.1.2. Okay, so my dear friends, have you done this? Okay, that's great. Now what you have to do is you have to click on close. There is a cross sign here. Click on close. Just see on the screen and then click on IP configuration. Check that IP you have given is correct. Click on close again and click on close once again. Okay, click on close. You just have to give the IP address. Done? Have you done for 192.168.1.2? Okay, that's great. Now, my dear friends, go to the third computer, and on the third computer, we have to give the IP address 192.168.1.3. Okay, so click on the third computer, click on this computer, and click on desktop. Click on desktop, and do you see IP configuration? The same way you have to do. Click on IP configuration and give the IP address here 192.168.1.3. Press the tab button and I will wait for you on this page. And the same way, if you have not given the first computer IP, give it 192.168.1.1. The process is same. Okay, that's great. Now, my dear friends, you have given the IP address to this computer. Now you have to click on the close button. Click on the close button. And if you want to cross check, close again and close. So this is how you have given the IP address to all your computers. Now, what I will do is I will copy the MAC address. Do not copy the MAC address. Okay. I am copying this because I have to explain you something. Now I will go to the second computer and I will type the command. I will go to the command prompt. Here in desktop, there is command prompt. And then I can type here command ipconfig space /all, enter, and I have to copy this MAC address, which I will copy, right click copy and paste, Control V, escape. Then I will go to the third computer, then I will click on the command prompt, ipconfig space /all, and then physical address. I will copy this address, copy, and then I will click here on the comment box and I will say Control V and escape. So this is how I've copied the map. Now, my dear friends, what you have to do is let's do the ping. Let's check whether we are connected to 1.2 and 1.3. Okay, so what we have to do is we have to go to this computer. Go to this computer, click on this computer, the first one, and click on the command prompt. So click on this computer. You're already in desktop. Do you see command prompt? Do you see command prompt, my dear friends? Okay. Now click on the command prompt, and after clicking on command prompt, you have to type the command ping. So remember, ping is the command which is used for checking the connectivity. So ping, and before typing ping, type on command arp space -a. Type this command arp space -a. What is the meaning of this command? I will explain you, but first type this command and you will see no ARP entries found. Do you see this? Just go ahead, type this command ARP space -a. Okay, done. Now what you have to do is you have to type, I hope you have done this and everyone can see no ARP entries, correct? Okay. Now the next thing is you have to type the command ping 192.168.1.2. That is your next computer IP address. Ping space 192.168.1.2. So are you able to ping? Is your PC sending ICMP echo packet and you are getting the reply? I will not be doing the ping because I want to show you something that when you ping, what happens in the backend. But you go ahead and ping it out. Have you done the ping? And you see that sent 4 packet, received 4 packet, 0% loss. Okay, that's good. Now, when you type arp space -a, what do you see? Do you see some entries there? Do you see that there is an entry of 192.168.1.2 and the MAC address of 192.168.1.2 is there? Right? Okay, that's good. So that's what we are going to understand now, that okay, what is this ARP entry and what happens in the backend when I do a ping. So for that I have to first take you to the theory. Okay, then we will understand the theory here and then we will see that in action. So my dear friends, when you do a ping, your PC, we all know that our PC creates an ICMP echo packet. ICMP echo packet. And this ICMP echo packet will look like this. The data will be ICMP echo packet, meaning any dummy data will be there. 32 bytes of dummy data is put here. Now this packet is ICMP echo packet. And in ICMP, we all know there is no port numbers. So there is source IP. Source IP address is my computer IP. Destination IP address is, we will see. Then source MAC is my computer MAC and then destination MAC is there. So the thing is, source IP address is my computer IP. Source is my computer, because from this computer PC1 you are pinging. So who becomes the source? The PC1 computer becomes the source. So what will be the source IP here? The source IP will be 192.168.1.1. Am I right, my dear friends? Okay, that's great. Now, what will be the destination IP address? What will be the destination IP address? You're right, you have directly given the IP. Okay, so there is no DNS query also. Your PC will not even look for the DNS because you have directly given the IP address. You say ping, the PC says okay, the DNS query part is not required. So directly I will create the packet. So here the IP address is 192.168.1.2. Now my dear friends, what will be the source MAC? Imagine the source MAC is AAA, BBB, and CCC. So this MAC, every computer, every network device has a MAC. This is this MAC. This is PC1 MAC, PC2, PC3. Okay, here it is PC0, so I will make it PC1 so that, okay, it says that you have to PC3. Now I will change the names so that we are in sync. Okay. Now, my dear friends, here this is PC1, this is PC2, this is PC3. So this is PC1 Mac, this is PC2 Mac, this is PC3 Mac. Okay. Now going ahead. So source MAC, I cannot put such a big MAC address here, 0000 0C9E3C04. So instead of that, I'm saying that, okay, this MAC is, you can say this MAC, consider this MAC as A, consider this MAC as A, consider this MAC as BBB, and consider this MAC as CCC. Okay, so I will use the word for MAC for PC1 MAC AA, for PC2 BBB, for PC3 CCC. Okay, now here what I will do is I will put the MAC, source MAC, meaning this is the source. So the MAC will be AAA. Am I right? Okay, that's good. Now what will be the destination MAC? What will be the destination MAC? Okay, so here the story of destination MAC. There is a story of destination MAC. Here the destination MAC will be the MAC of 192.168.1.2. You might be thinking that in the previous lecture, I have shown you that destination MAC is the MAC of the router. That part was yes. This part which we are seeing here, the destination MAC is will be the MAC of 1.2. Why? So the point is like, okay, when is the MAC of router and when is the MAC of the destination? Is there any logic in that? Is there any rule in that? So the answer is yes. So at this moment, I will give you an idea. If the source IP, and destination IP are in same network, then destination MAC is of destination IP. This is a golden rule. This golden rule will follow till the last lecture. Okay, this is now the golden rule number 2 comes into picture. So this is golden rule number 1. Now the golden rule number 2. This is the golden rule of networking. If the source IP and destination IP are in different network, then destination MAC is of default gateway, which is router. It can be a router, it can be an L3 switch. At this moment, to make things simple, I'm putting router. So today we are doing this. If the source IP, meaning what is the source IP? 192.168.1.1 is the source IP. If the source IP and the destination IP where you want to go, which is 192.168.1.2, are in same network. So in our case, they are in same network. The source IP and the destination IP, they are in same network. Now you might be wondering, like, who decides whether the source and destination are in same network? Okay, or if the source and the destination are in different network. So that is done by subnetting. We will understand that. That is a little bit complex, so I have not taken it right now, okay, because it will need some base to be developed. So that we will understand. At this moment, you have to understand this, that if the source IP and the destination IP are in same network, then the destination MAC is of destination IP. So in our case, the destination IP address is 192.168.1.2. The destination MAC will be of 192.168.1.2. So this is an example of golden rule number 1, which we have taken. The source IP and the destination IP are in same network. They are in same network. You don't need a router. Okay. For example, my dear friend, you live in a building. You live in a building, and your building, this is the same floor. You live in a building and you are in the first floor, and in the first floor only you have one of the friend who is just next to you. So will you go via the gate of the building to contact him? The gate, you consider the gate as the router. Will you come via the gate to contact him? He is living next to you. The answer is no, right? You and your friend lives in the same building. You will directly contact him. You will directly call him. You will not go via the gate of the building and come back, right? So that's the same thing here. When both the IP, when the source and the destination, they are in same network, the networking says that you are in the same network. You both of you are in the same network. You people don't need the help of router for communication. Both of you are in same network. The communication between you can be done without router. That's why when you did the ping, the communication happened. Why? Because they are in same building, they are in same network. But if the source IP and the destination IP, for example, from my computer 192.168.1.1, if I try to ping IP address like 5.5.5.5, example, Google IP, Facebook IP, Yahoo IP. So obviously, if Google, Facebook, Yahoo server is not in my company, it is not in my network. They are away from my network. They are they are over internet. So I have to connect them via router. So if the source IP and the destination IP are in different network, like you are from your computer, you are trying to ping to Facebook, Yahoo, Google. The servers are not in your network. Then the destination MAC will be of router, will be of the default gateway, will be of the router. Okay, so that's why in the starting lecture, everywhere in my case, it was destination MAC was of the router. Why? Because everything was beyond the router. My DNS server was also not in my network. It was over the internet. The Facebook, Yahoo, Google websites were also not in my network, not in my office. They are over the internet. So all the packets will go via the router. So that means here all things will go via the gate. I have to go outside my building. So I have to go via the gate. Have you got a top level view, my dear friend? This golden rule is very important. I will repeat this rule multiple times. If the source IP and the destination IP are in same network, then destination MAC is of destination IP. You don't need a router. You are in the same building. You can just contact everyone or whomever you want because you are in same network. But if the source IP and the destination IP are in different network, then you have to go via the router. Your traffic will go via the router. Okay. Example is from 192.168.1.1. You ping to 1.2. You ping to 1.3. They are in your network. Communication will be done. Example is from 192.168.1.1. You ping 5.5.5. It is not in your network. Packet will go via the router. Okay. Now coming back. So now coming back to this point. So my dear friends, that's why the destination MAC will be of whom? The destination MAC will be of 192.168.1.2, correct? Because here the golden rule number 1 will be applied. Source IP, destination IP are in same network. So destination MAC will be of the destination IP. But can you tell me, does your computer knows about the MAC address of 1.2? Your computer says, or the computer is talking with me, and the computer says that Zamir, I know my IP. I know my Mac. Okay, so you did a ping and I created an ICMP echo request and an ICMP echo packet. In the data, I just put some dummy data. The source IP, I put my IP because I know my IP. Source destination IP, I know because you have directly given the IP. If you had given a name, I will not be able to create this packet. I have done a DNS query and get the IP first. But because you have given a IP address directly, I have put the IP address directly. So I said, okay, so you got the source IP because it was your IP. You got the destination IP because I have directly given you the IP. You got the source MAC because you know your source MAC, you know your MAC, but the computer is talking with me and he says that, okay, I don't know the destination MAC. How can I know the MAC address of all other computers which are connected, which are in my network? I don't know them. I have no idea. There is no mechanism, meaning I don't know them at this point. So I said, no, the computer, what you're going to do, because here the golden rule number one is applied because source IP and destination IP, you both are in same network. You don't need a router. So if source IP and destination IP are in same network, destination MAC will be of 1.2. So the computer says, do not worry. I will not tell you to go and open up that PC2 laptop and copy the MAC and give it to me. I will not put you to job. I have a mechanism. The computer say PC1 says that we have an inbuilt mechanism to solve this problem. We need the destination MAC so of 1.2. So what I will do is I will create a ARP broadcast packet. I will create an ARP broadcast packet. So my dear friends, my computer says that I will create an ARP broadcast packet. And I asked the computer, like, what is the meaning of this R broadcast packet? What you're going to do? So the computer says that I will send a packet to everyone in the network that, hey, who is 192.168.1.2? Who is 192.168.1.2? This packet will be received by everyone. Everyone who is not 1.2 will ignore the packet, but the one who is 1.2 will reply me, will give me a reply, and when that computer will give me the reply, I will get his MAC address, because this computer will also create the packet. Source IP will be this computer's IP, source MAC will be this computer's MAC. So when that computer will give me the reply, I will get the MAC address of 1.2. So this is the logic I use. So I just go and shout, you can say that, hey, who is there? For example, in your building, you don't know your friends, you know that, okay, Atul is there, but you don't know Atul's room number. So you go in your building and you take a megaphone and you like go ahead and say, okay, where is Atul living? And everyone listens, Atul, 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 but only Atul will respond back, okay, I live in second floor and this is my room number, first floor, this is my room number. Okay, so the same thing your computer is doing. Your computer knows that this IP is in my network. I will send an R broadcast, everyone will get it, but only everyone will drop it and only 1.2 will reply, and when 1.2 will reply, I will get its MAC address. This is the logic of getting the destination MAC, getting the MAC of 1.2. Okay, that is known as sending R broadcast packet. Okay, so that is generally, in short word, it is known as send IP and get MAC. So my dear friends, how the ARP broadcast packet will look like. How the ARP broadcast packet will look like. The ARP broadcast packet will look similar to the ICMP echo packet, but there are some differences. So this is the ARP broadcast packet. Some dummy data will be there. Source IP address will be 192.168.1.1. Destination IP address will be 192.168.1.2 only. Source MAC will be, all these things will remain as it is. Source MAC will be AAA, but destination MAC will be a broadcast MAC. FFFFF, this is a broadcast MAC. So my dear friends, the computer creates an ARP broadcast packet. Remember, the computer, it creates a ARP broadcast packet because it does not know the MAC of 1.2. It will create an ARP broadcast packet, and it puts a general MAC, which is known as the broadcast MAC. So all the computers they are the part of this MAC. They belongs to this MAC address, they belongs to this MAC address, they belongs to this MAC address, meaning any packet coming to their, they belong to this MAC, meaning this is their MAC, they belong, this is also their MAC, this is their MAC, this is also their MAC, this is their MAC, this is also their MAC. Okay, so it is like they are part of this group, you can say. So my dear friends, your computer will create an ARP broadcast packet like this. Okay, now before going ahead, I will show you this in packet tracer. I will go step by step. Okay, and I will show you in the packet tracer. So for me as a trainer, Cisco has given a very beautiful option because Cisco knows that networking is really interesting. So for that, for trainers, they have given simulation. There is no need for the student to refer to the simulation, at least in the live lecture when you are doing with me. No, not required for you to go to the simulation and do the same thing which I am doing, because it is not required for you. Okay, when you refer the LMS at your home, you have enough time, you can do all other things. But if you do that, you will get stuck because simulation requires practice. Now I will go to simulation mode. In simulation mode, you did the ping, and what happened in the backend, that can be seen with the help of simulation mode. So I will go to the simulation mode and I will click on this computer. I will click on this computer. And my dear friend, now I will do a ping. You did the ping from the real time meaning real environment, meaning you connect the, you take a switch, you connect computers, you give IP, you do the ping. That Cisco is saying that, okay, in real environment, it will look like this. But if you want to see the backend, if you want to learn networking, then if I do a ping 192.168.1.2, the same ping which you have done, my ping will not complete yet. When I did the ping, what happened in the backend, it will show me. See here, this happened in the backend. Two packets are there. First, I will click on the blue packet. The color always changes. The blue packet is the type which is ICMP echo. And if I click on this packet and the packet says that the source IP is 1.1, the destination IP is 1.2, but the layer 2 is incomplete. Why it is incomplete? Because the source MAC and the destination MAC is, the destination MAC is not there. So first of all, you get a clarity that ping is created from at the layer 3 of the OSI model. Getting the point? That's what you can see. Out layer meaning, out meaning PC sending the packet out, going out from the computer. So that's why you see in the out layer. You can see this OSI model which we have learned. Layer 7 application layer, layer 6 presentation, session, transport, layer 3 network layer. Remember, I have told you that the ping is created from the network layer, and that's what it is. You can see here. The ping packet starts creating, the source IP and the destination IP is there added, but the layer 2 is empty because layer 2 says I don't know the MAC address of 1.2. I cannot complete this packet. I know the MAC, I want the MAC address of 1.2 because source IP and destination IP are in same network. Destination MAC will be of destination IP, which is 1.2. I need the MAC of 1.2, but I don't know the MAC of 1.2. So it will say ping, you are parked. You will not go, you cannot go, wait. And this ARP broadcast packet is been created and now it is ahead. And this R broadcast packet, you can see that the source IP is 1.1, the destination IP is 1.2, and the source here, here they have put everything at one place. And here the source MAC, if you see, 400C9E3C04. Okay, this is the source MAC, and the destination MAC is a broadcast MAC. Do you see this? The same thing which we have put here, source IP 1.1, destination IP 1.2. Source MAC, AA, destination MAC is a broadcast MAC. Have you got this understanding, my dear friend? Whatever we are learning, it is happening in the real environment. Okay, so your computer will create an ARP broadcast like this, and out meaning it is ready to go out. Okay, now I hope till here is it clear? Okay, so that's great. Okay, that's good. The next thing is, my dear friends, now this packet goes out from your computer. The packet goes out to the switch. It goes out to the switch. And now we have to understand the working of the switch. Now we have to understand the working of the switch. Okay, so the working of the switch is very important. And here there is an hub also, but hub is not used in today's word. Hub is a dumb device. Hub, if the switch was replaced with a hub, hub is a dumb device. Every time it gets a packet, it's sent to everyone. Switch is a intelligent device. Hub, you can say, is a very dumb device. Okay, and it is a device, whatever packet it will receive on one port, it will forward to all the port. The switch does not even read the packet. The hub does not even read the packet. That's why we say as hub as L1 device. Okay, hub is gone, hub is not used, hub is known as L1 device. If it was hub here, it will receive the packet and it will forward to everyone. Every time it will forward to everyone. Every time you send a packet to the hub on one port, it will forward to all the port. It will create multiple copies of the packet and forward to everyone. Okay, everyone who is connected, every time it will forward. So hub was very like unwanted, it was forwarding to everyone. So hub is gone, hub is not used in today's word. Hub was an L1 device, meaning for hub the packet which is coming is not a packet. It is for hub, it was a current. Hub says okay, current is coming, because it cannot understand anything. Hub works at layer 1, which is physical layer. So the packet which is coming, hub just create multiple copies of that, okay, and improves the current strength and forward to all the port. This was the only thing hub was doing. Any packet received on the hub, create multiple copies and forward to all the port. Now, some people says that hub broadcast. Hub does not broadcast. Broadcast packet is created by the PC. Hub and switch, they do not have the power to create broadcast packet. They just create multiple copies. Hub create multiple copies and send it to all the port. Every time this is the behavior of the hub. But the switch is intelligent, my dear friend. The switch is a layer 2 device. Now you will understand the meaning of layer 2. When we used to say that a switch is layer 2, what is the meaning of layer 2? The switch is an intelligent device. The switch says that I work at layer 2 of OSI model. That means layer 2 meaning switch can read source MAC and destination MAC of packet. So if the packet is coming, the switch can read the source MAC and destination MAC. It can read this layer 2 headers. It can read the source MAC and the destination MAC of the packet. And switch has a table known as the MAC table, which is the brain of the switch, which we will see. When switch receives any packet on a port, switch read the source MAC and make an entry in the MAC table. Now switch reads the destination MAC. Okay, so I will revise this. I will repeat this. Switch is an intelligent device. Now how it is intelligent? Whenever any packet is coming to the switch says that I am an L2 device. And I ask the switch, what is the meaning of L2? The switch says that I can read the source MAC and the destination MAC in the packet. I ask the switch that this our broadcast packet is coming to you. Can you read the source IP and the destination IP and the data? The switch says, no, we cannot. I cannot read source IP, destination IP. Data no one can read. Okay. So we are not allowed to read the data and the source IP and the destination IP. Router can read source IP and destination IP, not the data, but it can read source IP and destination IP. It can read source MAC and destination MAC because it is an L3 device. But I am an L2 device and I can just read a source MAC and destination MAC. That's it. Okay, whenever packet comes to any of my port, I read the source MAC and I read the destination MAC, and I have a table that is known as the MAC table. And the switch says that, you know what I do? I read the source MAC, meaning I come to know that on my port number 1, there is a computer having MAC address AA. So I need this information. And I ask the switch like, why do you need this information? The switch says that so that I can forward the packet to the right port. I just don't want to forward every packet to everyone. I am intelligent and I have to take decisions. And this MAC table help me to take the right decision, and which you will understand in some time. So what the switch says that when I receive this R broadcast packet, I stop the packet. Every time when I receive a packet, whatever packet it is, I stop the packet and I read the source MAC of the packet. And then I make an entry on my in the MAC table that on port number 1 there is a Mac living. I don't know whether it is a computer or a computer or a server or a printer. I don't know anything. The switch says I just make an entry of the MAC address. I understand via MAC addresses. So when I receive a packet, I read the source MAC and I make an entry in the MAC table that on my port number 1 there is a network device having a MAC of AAA. Then I ask the switch, then what do you do? The switch says that because I have to take the decision to forward the packet, so I read the destination MAC. And I read the destination MAC, and then when I come to know that the destination MAC, when I read and I see that, oh, it's all this is a broadcast MAC. This is a broadcast MAC. This is a broadcast MAC, meaning this is a broadcast packet. This packet is for everyone. This packet is for everyone, because when I read this MAC, I know that this is a broadcast MAC, and I know that this packet is for everyone. So what I do is I create multiple copies of this packet and send to all the port. I create multiple copies of this packet and send to all the port. So it creates copies of this packet, and how many ports are there? 24 port is there, 48 port is there, how many computers are connected? It will send the packet to all the ports. Okay, so that's what is written here. Switch is an intelligent device. Switch works at layer 2 of OSI model. Layer 2 meaning switch can read the source MAC and destination MAC of the packet. Okay, so whenever any packet comes, switch will stop, do not go. I will read your sales source MAC, and then I see that you are coming on port number 1. I will make an entry in the MAC table. Then I will read the destination MAC. Oh, you are a broadcast packet. You have a broadcast MAC. I have to, if the destination MAC is a broadcast MAC, now the switch reads the destination MAC. If the destination MAC is a broadcast MAC, the switch create multiple copies of the packet and send it to all the port. If the destination MAC is a unicast MAC, which I will explain you when we go with the flow. So my dear friends, the switch creates multiple copies of this broadcast of this packet and send it to all the port. And the command to see the MAC table is of the switches show MAC address table. Okay, this is the command. Show MAC address table is the command to see the MAC table of the switch. So my dear friends, have you got an understanding about the switch? Okay, that's great. Now I will take you back. I'm still in simulation mode, okay? And I will take you to the switch. You can also do with this, but you be in real time. Okay, you be in real time and click on the switch and click on CLI. Click on the switch and click on CLI. Have you click on switch? Have you click on CLI? Have you click on switch? Have you click on CLI? In networking, we do the configuration using command lines. The commands are simple. The commands are easy to understand. There is no need to worry. Remember, in networking, the concepts are very important. Commands are very simple. Now, here you have to type the command show MAC hyphen address hyphen table. If you type the command wrong, it does not work. In my case, the MAC table is empty. In your case, it will be full. Show MAC hyphen address hyphen table. Just go ahead, run this command. Do not make a mistake. MAC mac -address -table table. Just give it correctly and it is going to work. Done, my dear friends. Have you run this command? Okay, that's great. Now, in your case, it will be full. In your case, okay, showing empty. Oh, it is showing empty because it keeps the MAC entry only for 5 minutes. They are temporary. Okay, so in your case, it is empty because 5 minutes has passed. For 5 minutes, if the computer has done no activity, it will remove that entries. So these entries are not permanent, they are dynamic entries. So they are only for 5 minutes. Getting the point, my dear friends? So that's why your entry is empty, because for the last 5 minutes you have not done any activity on the computer. Okay. Anyways, I have done nothing. Okay, so in my case it is blank. Just see here, if this MAC, I will take this packet forward. Okay, with the help of simulation I can control. In real life it is 5 minutes. In packet tracer also it has to be 5 minutes. Now my dear friends, here I can control the flow. So if I just see, if I click on this button, my dear friends, if you see this, if I click on the right button, the packet will go one step ahead. See here, tick, and the packet goes, the R broadcast packet goes to the switch. And here, let's see, okay, whether it has learned. So you can see here there is a VLAN. As of now, we will ignore it, but at the right time we will learn VLAN. And you can see that it has learned dynamic. Dynamic entries are only there for 5 minutes, meaning if there is no activity after 5 minutes, they are been flushed out. And you can see that in this is fast Ethernet 0 bar 1, fast Ethernet meaning 100 Mbps. This switch supports 100 Mbps. It is not a gig switch. It is a fast Ethernet, meaning it supports 100 Mbps of data transfer. And this is the port number 1 on which I have connected. And my dear friends, here it has learned the MAC. If you see this, that on port number 1, the MAC is AA. So if you see on the switch, it has learned the MAC, that on port number 1, there is a MAC like this. Getting the point? So if you see this, it has learned the MAC 000C9E 3C04. This 3C04 it has learned here. That on my port number 1, there is a MAC, there is a MAC address. Okay, there is a network device. It can be anything, computer, laptop, server, it can be anything. So normally in production, in at your most of the time it will be computers and laptops in your offices. So here, do you see this? The same thing which we have learned, the same thing is happening. Now it has read the source MAC, it has made an entry in the MAC table. Now it reads the destination MAC, and it says that, oh, you are an R broadcast packet. I will create multiple copies for you and send it to all the port. See here, it will send it to all the port. Right now only 2 ports are there. So obviously it will not send the packet on the same port which it has received. So it has received on port number 1. It will send on port number 2 and port number 3. See here, tick. Getting the point? Now, my dear friend, this computer drops it. This computer says that, you know, I am not 1.2, I'm not 1.2, I am 1.3. So this R broadcast packet is not for me. I will not reply, and it has dropped the packet. It has dropped the packet. And now this computer is ready for the R reply. So R broadcast will be received by everyone. The switch will forward to everyone. Everyone will drop, but only one computer will reply for whom it is. And now in our case, it is for 1.2, and 1.2 is ready for the reply. Now let's go back and see how the reply will look like. So my dear friend, how the reply will look like. So the ARP reply from PC1, sorry, from PC2 to PC1. Now the ARP reply will be like this, where the data is like any dummy data will be there, and the source IP address, the destination IP address, the source MAC, and the destination MAC. In ICMP and ARP, only these four headers are there: source IP, destination IP, and source MAC and destination MAC. Source IP will be whose IP address? What do you think? Source IP address will be whose IP? Now the computer is ready for the ARP reply. So this ARP reply packet is getting created. Correct. You are right, my dear friend. So the IP address will be of 192.168.1.2. Okay. What will be the destination IP? Okay, that's good. So what happens? For example, when I receive a letter, from and to, I receive a letter. I receive a letter from my friend. From is my friend address, to is my address. After receiving the letter, if I want to give a reply to this letter, so what will happen? The two, will become from. From will be my address, and to will be the friend's address. Okay, so the from will become to, and the to will become from. The same way here, the source IP will become destination IP. The source MAC will become destination MAC. Okay, and source IP will be my IP. Source MAC will be 1.1.2 IP. Source MAC will be 1.2 MAC. Okay, so the computer says, PC2 says that I got the ARP broadcast packet now. So I know whom I want to reply. I want to reply to 1.1. And I know the MAC of 1.1 also, because I received the ARP broadcast. I know source IP is there, that will become destination IP. Source MAC is there, that will become destination MAC. So here it will become like this: 192.168.1.1 source, and the source MAC will become destination MAC. And obviously, so from the reply is going from PC2. So PC2 is the source, so his IP will be there, and his MAC will be there. So is this clear, my dear friends, how the ARP reply packet is created? Source 192.168.1.2 says, I know my IP, I know my MAC. The destination IP I will get from the ARP broadcast packet. The source IP will become destination IP, source MAC will become destination MAC. Okay, now you have to tell one thing. That one thing is, my dear friends, look at this packet carefully and tell me whether this packet is a broadcast packet or whether this packet is a unicast packet. You can answer anything, meaning do not think that if I'm asking, I am checking anything. No, I am always learning. Even I also make a mistake, and I'm also always like, if you rectify me, I will always be ready for rectification. Okay, so we are learning. Okay, even as a trainer, I always get good things from you people. So coming back, so my dear friends, okay, so the answer is perfect. The answer is unicast. So it's a unicast packet. And if you remember, unicast meaning one to one, okay, and broadcast meaning one to all. So here you have seen the example: ARP broadcast packet, one to all. Destination MAC was for everyone. But this is a unicast packet. Okay, ARP reply is a unicast packet. Clearly, source IP is a 1.2, destination IP is of 1.1, source MAC is of BBB, destination MAC is of AA. Clearly, their MACs are there. Broadcast MAC is not there. Clearly, their MACs are there. So it is a unicast packet. Okay. So ARP reply is a unicast. So my dear friends, this packet will go to the switch. It will go to the switch on port number 2, and the switch will say, wait, stop. I am a switch and I'm an L2 switch, and I will read the source MAC, and I will make an entry in the MAC table that on my port number 2, BBB is there. Then I will read the destination MAC, and oh, but your destination MAC is not a broadcast MAC. Now switch read the destination MAC, point number 2. If the destination MAC is a unicast MAC, then the switch refers the MAC table. The switch says, oh, you are a unicast MAC. Directly MAC is given. Oh, then I have to refer the MAC table. So if the destination MAC is a unicast MAC, like this, okay, AAA, unicast MAC, direct MAC is given. Then the switch refers the MAC table. Then the switch says, I will refer the MAC table and forward the packet to the right port, and forward the packet to the right port. What is the meaning of this? The switch says that, I have read the destination MAC, and your MAC is a wait. I will not forward you to all the port. I am not hub. Hub forward to every port because hub cannot read source MAC and destination MAC also. For hub, it is just a packet, a current which is coming, and it has to forward, but every time he will forward the packet to all the port. If the hub was there in replacement of switch, hub will always send the packet to all the port. Hub does not even know whether it is a unicast packet or broadcast packet, but switch says I am intelligent. I can read the source MAC and destination MAC, so I know that it is a unicast packet. And I will forward you only to the port where A is there. So the switch says wait, packet wait. I will refer the MAC table. And the switch refers the MAC table. And my dear friend, when the switch refers the MAC table, the switch says, hey, you are on port number 1. AAA is on port number 1. And you know what I will do with you? I will forward you only to port number 1. So the switch forwards the packet only to port number 1. So the switch is not forwarding to everyone. So unnecessary flooding of packet is reduced. Imagine you have thousands of computers, hundreds of computers. If the hub was there, hub was forwarding the packet to everyone, and so many flooding of packet and unnecessary resources were utilized because unnecessary packets were issued by everyone. Everyone has to drop the packet. Okay, imagine this ARP reply going to PC3. What it will do? It will drop it. It says it is not for me. This packet is for 192.168.1.1. So my dear friends, hub was a very dangerous device. Hub used to forward the packet to everyone, but switch is an intelligent device. The switch says that I have read the destination MAC and my destination, the destination MAC A, and I have referred the MAC table, and I will forward you only on port number 1 because you have to go there. I will take you there. So see here. Okay, this is the reply. This is the reply which is going from the PC. This is the out, meaning ARP reply. It will go like this. Source IP is 1.2. Okay, source IP is 1.2. Destination IP is 1.1. Source MAC is 4438. 4438 meaning BBB. Okay, you can see 4438. And destination MAC is 3C04 AAA. 3C04 AAA. Okay, here in our example, they are BBB and AA. Now this packet is ready. Out meaning the packet will go. In meaning the packet, the ARP broadcast packet was received like this to PC2. Out meaning the ARP reply is going like this. Okay. So in meaning ARP broadcast packet was received. Out meaning ARP reply is going out. So my dear friends, I will take this tick. The packet goes to the switch. And the switch says that, oh, let's see whether it has read or not. The switch says, oh, that's great. On my port number 2, there is a MAC 4438 meaning BBB. 4438 meaning BBB. So The ARP reply goes, the switch reads the source MAC, make an entry in the MAC table, the entry is done. Now it reads the destination MAC, refer the MAC table and forward on port number 1. The same thing it is going to happen here. You will see that this packet will be forwarded to port number 1. See here, tick, and it is forwarded here. Now your PC 1 is happy. You know why it is happy? You know why it is happy? It is the birthday of PC 1. So you know, right? It is why it is happy. It says that yes, I am happy because I have got the MAC address of 192.168.1.2, and now the ICMP echo packet is ready to go. Getting the point? So that's why the ICMP echo packet, if I click keep the mouse type is ICMP, the ICMP echo packet is ready to go. Okay. Now one thing here, this computer is also very smart. Before taking you to the ICMP, the computer is also very smart. The computer says that if this person tries to ping one more time, then should I send the R broadcast again and again? Then unnecessary broadcast packets are sending. What I can do is, I know that okay, after so many effort, I sent the R broadcast packet, I got the reply. Then I came to know that the MAC address of 1.2 is BBB. You know what I will do is, I have a table, and that table is known as the ARP table. So this computer PC1 says I have a table, and all computers have this. So I have a table, and that is known as the ARP table. And you know the computer, it is not MAC table, it is ARP table. So ARP table has two things. One is your IP address will be there, 192.168, and the MAC address will be there. Okay, so the computer says that, you know, after sending the what I needed MAC of 1.2. So what if this person ping once again, then should I send the R broadcast again? No. So I got the reply now, so I will keep this in my ARP table. Okay, and this ARP table is like temporary. If you restart the computer, the ARP table will go away. If you want to manually flush the ARP table, then you can do R space -D. And if you want to see the ARP table, R space -A is the command. If you want to flush the ARP table, R space -D, instead of A, just type D. It will delete the ARP entries. And if the ARP entries are deleted, then your PC will send the ARP broadcast again. But if the entry is there in the ARP table, this computer, if you ping once again, it will not send ARP broadcast. It will say, why I will send ARP broadcast? I already know the MAC of BB1 1.2, it's BBB. I will show you that. But as of now, my dear friends, your computer says that okay, I will, before sending the ICMP echo packet, I will make an entry in the ARP table. Okay, and I cannot show you that right now because if I break this ping, the flow will break. Okay, so to show you ARP space -A, I have to break this ping using Control C. If I break this ping, the flow will break. I will show you after some time when the complete ping is done. So my dear friends, now the ICMP echo packet is ready to go. So what the PC will do? The PC will take the ICMP echo packet. ICMP echo packet. Okay. So the data is like some 32 bytes of data, source IP address, destination IP address, source MAC, and destination MAC. And my dear friends, source IP will be 192.168.1.1, destination IP will be 192.168.1.2, source MAC is AAA, and the destination MAC is not there. Now your computer knows about the destination MAC. Okay, now this ICMP echo packet is ready to go. Correct, my dear friends? So now this ICMP echo packet is ready to go. Okay, so now I will click this, the ICMP echo packet will go. Now my dear friends, now when this ICMP echo packet goes to the switch says that okay, wait, packet wait, where it will read, I will first read the source MAC. Okay, I will first read the source MAC, and then it says, oh, your entry is already there. Okay, I will refresh your entry for more 5 minutes. Communication is going on, meaning you can stay for more 5 minutes. Entry is refresh. Communication is not there, your computer is turn off, switch off. Okay, after 5 minutes the entries are removed. Communication is going on, entries are refreshed, and they can stay for more 5 minutes. These are dynamic entries. They're known as dynamic entries because switch is learning on its own. So is there any static entry? Yes, I will explain you that in port security lecture. Now my dear friends, so it reads the source MAC and it says that, oh, entry is already there. Okay, then it reads the destination MAC and it says that, okay, where you want to go? You want to go to BBB. Oh, BBB is on port number 2. I will forward you only on port number 2. Getting the point, my dear friends? That is the intelligence of the switch. So first of all, tell me that this ICMP echo packet is a unicast packet or broadcast packet. Now it is simple for you to answer. Perfect. The answer is it's a unicast packet. Okay. Now the packet goes, I will show you this. The packet goes and the switch will see here. The switch will forward only to this port. Okay. Previously, the R broadcast was forwarded to all the port because it was a broadcast packet. This is a unicast packet and the switch is forwarding only to this port. So the ICMP echo packet is received. Okay. Now what this PC will do? Can you tell me, my dear friend, what this PC will do? What do you think? Are you awake or are you asleep? So you have joined a networking course. Okay, networking. I take MCSE also, I take Azure also. Both are Microsoft products and both are graphical. Both are graphical, meaning from maximum start to end in Azure, at least in from the first lecture till the second last lecture, complete practical is there, full third fold practical graphical. Last lecture I do migration, which only I can do. I want to show AWS to Azure migration, and in MCSE after one to like second lecture the practical starts, and till the last lecture it goes complete graphical because Microsoft is famous in graphical, but networking is famous for concepts. A network engineer is a troubleshooter because he knows how things are working in the backend. People will come and ping and go, but a network engineer knows about the backend stuff. So echo packet reply, you are right, Surajit bhai, and it will give the ICMP, it will create the ICMP echo reply. Okay, so it's an ICMP, it's not TCP. So in TCP the acknowledgements are there. Remember, TCP acknowledgements will be there, three-way handshake is there. UDP, no three-way handshake, no acknowledgement. In ICMP also, no three-way handshake, no concept of acknowledgement. It is only in TCP, HTTP, HTTPS. It is ICMP. Getting the point, my dear friends? So that's why you don't see any acknowledgement concept here, any three-way handshake here, because it is ICMP protocol. So three different protocols are there. TCP behavior is different, UDP behavior is different, ICMP behavior is different. And one more protocol you have seen today. Can you tell me what that protocol is? It is R protocol, address resolution protocol, R protocol. It is required when your computer does not know the MAC address. Okay, so it send the IP and get the MAC. Now, my dear friends, so this ICMP echo reply, now it gives you an understanding that I have received the ICMP echo packet like this. Okay, 1.1 to 1.2, AAA to BBB. Now reply will be from 1.2 to 1.1, BBB to AAA. That's what I will create here. So the ICMP echo reply will go like this. So data, and this is the ICMP echo reply. This is the echo reply packet. This is the echo reply packet. So source IP will be 192.168.1.2. Source IP will be 192.168.1.2. So destination IP will be 192.168.1.1. Source MAC will be BBB, and uh, destination MAC. Okay, destination MAC. Destination MAC will be a, the source IP become destination IP, source MAC become destination MAC. Okay, destination MAC become this, source IP from to, from becomes to becomes from, the same thing. So my dear friend, this is the ICMP echo reply. Now this ICMP echo reply will go from your computer. Okay, it will go from PC to, it will go to the switch. The switch says wait, packet waits, where you want to go, and the packet goes to the switch port number 2. The switch reads the source MAC and it says okay, port number 2 BBB already there. Okay, I will refresh you for 5 more minutes. Then it reads the destination MAC. Destination MAC, where you want to go? You want to go to A. You want to go to this destination. Okay, wait. I will refer the MAC table. Oh, A is on port number 1. I will forward you only on port number 1. I will forward you only on port number 1. I am not have to forward you to everyone. So see here, tick, and only on port number 1. And my dear friends, if you see, do you see the reply came? And it took 8 milliseconds. So anyways, do you see the reply came? The first ICMP echo reply came, echo packet went, reply came. When you ping, you just saw the reply, but have you understood what happened in the backend just for one reply coming? We took 1 hour, approximate 30 minutes or 40, something like this. Okay, so now my dear friends, coming to this point, the same way, if I say tick, the same way the next ICMP echo packet will go, this the same way. Now I will go to real time. The same way all other ICMP echo packet will go and the reply will come. Okay, first packet, because I have played a lot, so the time is too much. But here you can see they are very fast and all other packets are sent, and echo packets are sent in the same way. Next echo packet will go, the reply will come. Third echo packet will go, reply will come. Fourth echo packet will go, reply will come. So it is saying us that send for, received for, 0% loss. Okay, and this is the ARP table. This is the ARP table. 1.2, this is the MAC. The MAC is BBB. Now, my dear friends, tell me one thing. If I go to the simulation and if I do a ping, once again, if I do a ping, will it send the ARP broadcast packet again? What do you think, my dear friends? Will it send the ARP broadcast packet again? Correct, you are right. The answer is no. And that's what we can see in the simulation. And if you can see the R broadcast packet, it does not send, say it says that I am directly sending the ICMP echo packet. If I click here on the packet, type is ICMP, source IP is 1.1, destination IP is 1.2, source MAC is AA, destination MAC is BBB. Directly it will send the ICMP echo packet will go, okay, and it will go here. The ICMP echo reply will come. Okay, the next ICMP echo packet, packet tracer is not showing. Why it is not showing? Okay, it is showing with different colors. Okay, it is showing with different color. Okay, fine, that's fine. Okay, anyways, so all the echo packet will go, echo reply will come, and then the ping results can be seen. Now, if I go and if I delete the ARP table, ARP delete, now the ARP is empty. Now, my dear friends, if I go to the simulation and if I do a ping again, okay, if I do a ping again, now you can see it is sending, let's say that I have to send the broadcast packet because I don't know the MAC address of 1.2. Getting the point? Then the same story will go once again. Okay, now coming to the next point, now I will go to real time. And here you can see in my case, my dear friends, here I can see the port numbers. Do you see 0 bar 1, 0 bar 2, 0 bar 3? These are the port numbers, right? These are the port numbers. In your case, you people might not be seeing this. So you have to click on option. Do you see option? You have to click on option, and do you see preferences? preferences. So please click on option, please click on preferences, and you have to click on always show port labels. Do you see? Always show port labels in logical workspace. Do you see this? Always show port labels. Just click on that. No need to save. Okay, so have you click on always show port labels in logical workspace, my dear friends? Have you click on that? Okay, that's great. Now you have to click on the switch. Now, my dear friends, click on the switch and click on physical, click on physical, click on physical. So my dear friends, click on the switch and click on physical, click in zoom in, click on zoom in, click on switch, click on physical. Whatever I have to do, I will always do in the real time. Okay, simulation, it is stop. Simulation meaning all functionality stop. Then you have to tick, 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 and then it will go. Okay, the way at the very start you did ping. In real time, it will just go and do the ping. Real time meaning real environment, production environment. It is work like that. But simulation, it is for us for understanding how things are working in the backend. So that's why we always use packet tracer for learning, because this is the best tool to learn networking. Now the thing is, I will click on switch, and my dear friends, if you click on CLI, sorry, if you click on physical, you can see here there is a console port. Do you see there is a console port? This port is required. This port is required to connect to the switch. Okay, so there is a console port, and there are how many ports are there? From 0 bar 1 1 2 3 4 5 6 7 8 9 10 11 12. So it's a 24 port switch. It's a 24 port switch, and this is fast ethernet. Okay, 2960 is fast ethernet, and 2960L is advanced. It is gig port, meaning all the ports are gig. If you compare this with 2960L, okay, if you compare this with 2960L, if you remember, in 2960L it was PoE, it was power over enable port. Remember, in the first lecture I've shown you. And L is equal to gig port, no, meaning fast ethernet meaning 100 Mbps. 2960L, you can say L meaning they have their version name, actually, meaning they have introduced like that. So, but L is not, that's a good point, but L is not gig port. Now, my dear friends, because it's an advanced switch, so in today's world, all the switches has to be gig. So it is having gig port, and it is having ports for fiber module also. This 2960 is not having. That means in this 2960, you cannot connect fiber modules, and it has a old way of connecting the console. In 2960L, there is a latest way to connect to the console. So I will just give you an idea by opening up that also. So do not worry, my dear friends, we are at the ending of this session. Okay, few things we will take. By when I say that we are at the ending of this session, you can pass a message to your family members. Okay, keep food ready. I am coming. Now, here what we have is, in this case, we have seen it's a 2960L, and here all the ports are like 1000 Mbps. They are gig port, and PoE plus, meaning yellow marking around the port indicates that the switch is a PoE switch. It can support power over Ethernet. This 2960 switch does not have that yellow marking, but here I need to check, because there is a yellow mark here. So I have to check the data sheet whether it is PoE enabled or not. I have to check this. Yellow mark is there, but not clearly the way it is in the rounded one. Okay, so I have to cross check. Now, the next thing is, here we have 5 and 6, a latest way to connect to console, meaning directly from your laptop. a USB, you can use a mini USB cable and you can connect. Okay, and there is an old way to connect to console. Console is required when you want to configure the switch. So when you get a new switch in your company for the first time, you have to configure it. And that's the job of the network engineer. We have to configure the switches. We have to give host name. Sometimes we have to give IP address to the switches. Okay, for monitoring purpose. I will give you an idea how to give an IP address to the switch. That is an interesting part. Now, the next thing is here, there is a USB port. This USB port, you can connect a pen drive and perform iOS upgrade. But here there is no way. This is not having that advanced facilities. USB is not there. Okay, and console is also only one. And here SFP module facility is there. You can connect a fiber. Here fiber is not there. It is having 2 gig port. It says that you want to connect to one more, connect to switches. Okay, we are giving you 2 gig port. Okay, so this switch is having fast Ethernet. But do not worry, concept of all the switches are same. Only few things are upgraded. As per the technology, few things are upgraded, like it is having 100 Mbps, it is having 1000 Mbps, but the switch concept which we have learned is common, and not to in Cisco. Any company switches you take, their working is common. Whatever we are learning about switches, about routers, whatever we are learning, they are common in all the company, any company network device. Like Juniper is also a company. Okay, the way Cisco is there, but Cisco is very big company. So their devices, the concept is same. Switches internationally work the same. Router internationally work the same. Let it be of any company, any vendor. Now, my dear friends, if I click on CLI, here I can see this is the command to run the MAC address, and because no communication is going on, so the entries are removed. Now just come here and type the command show IP interface brief. Show IP interface brief. Show IP interface brief. So my dear friends, this is the command. It will show you the interface status. So you can see that it's a fast Ethernet, and we have connected 3 PC. So all the 3 ports are up. So how many ports are there? 24 ports are there. 2 gig ports are there. Okay, there is a VLAN one which is used to which we used to give IP to the switch, which I will explain you the concept of VLAN. But here you can see the fast Ethernet meaning it's 100 Mbps and gig meaning 1000 Mbps. So it is having 2000 Mbps port. And 2960L, all the ports are fast Ethernet, all the ports are gigabyte Ethernet, meaning they are 1000 Mbps. Have you run this command, my dear friends? Further in upcoming session, we are going to learn lot of commands. So do not worry. At this moment, I just wanted to show you this. Okay, so that's it for this session. I would like to thank you for attending this session. Let's meet in the next session. The session completes today. Just to clarify, group switch is meaning switch which is connected as 2 combination switches online and backup. There is no group switch, Rajesh bhai. There is stack switch. Meaning if some company wants to have multiple switches at once, they can stack them. That is known as stacking of switches. Grouping meaning in networking, it is known as stacking. There is a cable. Using that cable, we can connect in the, there's a physical connectivity. We can connect one switch to another switch and they will behave like one. It is like that. Now, my dear friends, so that's it for this session. Like cluster, correct, you can say. That is known as stacking of switches. But every switches does not support stacking. There are models. Switches model, you have to pay more. That's why different model is there. Working is same, but different models are there. Pay more and get more facility. So, my dear friends, the session completes for today. So let's meet in the next session. So bye everyone.